When beginning this project, I established 8 criteria for success, or CFS. The first of these was the development of a successful login function where students could create and log into different accounts. This was entirely accomplished. Actually, new users must register with an account. So when registering, certain requirements must be met. As you can see here, it says password must have at least 8 characters, one number, uppercase letter, and lowercase letter. If this requirement is not met, the user is prompted with a notification. So we'll give a bad password. And here we clearly have this notification telling us to meet the requirements. So the user can fix this, give a correct password, and they're successfully registered. So that's just a quick example of error handling in my program. Once they're registered, they can head to the login page and log into their account. Here we'll go test user 1 and password 1. So my second criteria for success stated that students would be able to choose between studying, quizzing, or viewing their score history. Once a user successfully logs into their account in my program, they're presented with this hub page showing precisely these options. Additionally, my third CFS established that there'd be a welcome screen or something of that sort. This page would have to allow for simple navigation to whichever page the student desires. And as these two criterion went hand in hand, they were both met. So the fourth CFS declared different study options, such as clicking on different points around the unit circle and viewing their coordinates, or viewing a trigonometric formula page. This criteria for success was partially met. When the user selects the study option, they are presented with options for both of the things outlined in the CFS. The formula page is identical to the one in the CFS. As you can see here, it includes helpful definitions as well as simple tricks like SOHCAHTOA. However, the unit circle path is considerably different. When accessing this page, a unit circle figure through Matplotlib is displayed, and this is pre-annotated and not interactive in any way outside of the implicit Matplotlib functionalities. To account in some manner for not meeting this original CFS, I implemented a trigonometric slider where the user can change theta from 0 to 2 pi, and the corresponding trig values are updated in real time in that box. So my fifth CFS similarly revolved around the user's access to different quizzing options. This included evaluating trigonometric functions for different theta values and converting between radians and degrees. I successfully developed both of these quizzes and thus met this criterion. These two quizzes function in very similar ways. Taking the radians and degrees quiz as an example, 10 questions must be answered to complete the quiz. The student is provided with 4 random choices for each question. Just skipping through here, you'll see that the wrong answers can be duplicated, but the correct answers will never be duplicated. And after each question, the student is told whether they were correct or incorrect, and the correct answer is displayed to either reaffirm what the student said or to help them learn. So after 10 questions have been answered, the student is presented with a completion box. The message in this box corresponds both in color and text to the user's score. So really good score, you're going to get a green message that's cheering you on. However, a 1 out of 10, as we got here, is going to recommend you head to the formula page and study up in red text. So this completion box actually relates to my sixth CFS, which stated that if a student struggles in one area particularly during quizzing, feedback is given and they're suggested to try a certain respective studying material. This was successfully implemented as obviously if the user scores low enough, they're suggested to go review one of the study materials, which the study material suggested depends on the quiz. So here we're suggested to go to the formula page as that contains the conversion rules for radians to degrees. My seventh CFS stated that users' quiz scores must be stored to their account and accessible. This criterion was only partially met and also highlights the largest pitfall of this program. Whenever a matplotlib figure is to be rendered, a new thread is started. However, threads can only be started once. So if a user attempts to open, let's say, the unit circle twice during their same usage of the program, that same thread will attempt to be started, and this returns an error crashing the program. This also means that a student cannot view their score history, proceed to take a quiz, and then view their updated score history. Hypothetically, the data has been updated in this scenario, but it's just inaccessible. Additionally, once a matplotlib figure is opened, any separate figures generated will display the first figure, not the correct one. For example, if we head to the scores page, the scores is just going to display the unit circle. However, if the user restarts the program, they will be able to view their scores as we'll do here. So these functions do technically possess the ability to meet my criteria for success, but it does so in a way that's very susceptible to error. So logging back in here. showing scores. And here we have one score for the one test we've taken where we got a 1 out of 10. So my final CFS was based around the concept of user friendliness. At its core, this program was to be developed for students at my school who cannot be expected to have access to any technology other than their school iPads. Therefore, this project would ideally be tablet compatible. I did not fully meet the requirements of this criterion in the way that I had hoped. No parts of this program necessarily fail to function when run on a mobile device, but it is a less than optimal experience. The GUI is inconsistent when recognizing touchscreen input, especially with the theta slider on the unit circle page. However, the largest shortcoming of my project in reference to this criterion is definitely window sizing. The program, as seen in this recording, fits well on a desktop monitor, but when it's converted to an iPad screen with much smaller resolution, GUI elements can begin to overlap, which makes the program unusable. I took many steps to make the program as mobile friendly as possible, like making element positions relative to the size of the window, but the set sizes of the elements themselves make certain window sizes unplayable. So just a couple of suggestions for improvement if I were to recreate this project. Firstly, I choose to make the GUI through tkinter as opposed to ThorPy. While ThorPy did allow me to easily make an effective GUI, it's relatively unpopular, and because of this, it's not very well documented or integrated with other common libraries. Whereas tkinter would give me a wider range of options for changing screens, adding elements, and implementing different libraries throughout. Additionally, I'd probably want to learn more about multi-threading to improve this program. Hypothetically, finding a way to access a thread that's already running or stopping a thread so that it can be run again are just two possible ways I could avoid the conflict of starting a thread twice. On that note, I'd also want to reconsider my usage of Matplotlib. This library is incredibly powerful for modeling data, but it's also a very high level library commonly used for projects far beyond mine in scope. It took a lot of time to learn, and my program just does not need such a complex thing. So it would probably be more beneficial for me to save user data to, let's say, a spreadsheet and graph it from there. I'd also like to reimagine the unit circle page. While conceptually it figured to be beneficial, it really proved to be somewhat clunky and out of place. I'd likely replace this page with some sort of interactive flashcard sets and a more official diagram of the unit circle, maybe an image file as opposed to a matplotlib figure. And lastly, I'd rework the quizzes slightly. In my current program, they are functionally perfect. However, each question of a quiz being given the same format can disengage the user over time. So to improve this, I'd probably introduce another randomly generated variable. This would decide the style of question the user is prompted with, as in they could type in an answer, drag multiple answers to their correct locations, or multiple choice, etc. This would further vary the quizzes and create a much more engaging result.